Hello everyone. We have gathered some observations from this unit circle in our previous videos. Those who haven't seen those videos, my request to them is that first you have look at those videos and then you try to understand things from this video. Now, in this unit circle, positions A, B, A dash, B dash, how they are important to us. This was discussed. There was a point P as shown here also, such that OP makes angle theta with positive x-axis. And why are those positions A, B, A dash, B dash are important to us? That you already know. Some information I have written here like their coordinates. And now we will try to have more observations, or rather I should say more applications of the previous observations we will have in this video. Now look at the position A. Now position A we had discussed as before has angle theta as 2n pi. Even multiple of pi was the angle attached with position A. This we have already seen. And also from the picture you can see that x coordinate is 1. And what does x coordinate refer to? X coordinate means cos of angle at that point. That means cos of theta if I am saying. Then now at this position I will be calling that x coordinate 1 as cos of 2n pi. So what do we observe here? That cos of 2n pi is 1. This is my first observation. I am trying to connect two things, x coordinate of point A and the angle attached with point A or position A. Now, similarly, I observe that y coordinate is 0. And what does y coordinate refer to? It was sine theta. And what is theta at position A? It is 2n pi. This is already written here. So sine of 2n pi is 0 that I can collect from here. Okay, this is about position A. Now look at the position A dash. Now at position A dash, angle is odd multiple of pi. This we have already learned. And here I observe that x coordinate is -1. What does x coordinate refer to? Cos of theta. And what is theta? 2n plus 1 into pi. So that -1 is nothing but cos theta, means it is nothing but cos of 2n plus 1 into pi, or I can say cos of odd multiple of pi. So we observe from here cos of odd multiple of pi is -1. Now what about its y coordinate? Point A dash y coordinate. It is 0. That means I observe that sine of that theta, theta means now odd multiple of pi, is 0. So sine of 2n plus 1 into pi is 0. Now here wherever I am writing n, please don't forget that n is any integer. Okay. Now let us go to position B. Now position B also is conveying something. Now position B was having angle theta as 2n pi plus pi by 2. Okay. And here x coordinate is 0. That means x coordinate means cos of theta, means cos of 2n pi plus pi by 2. That is nothing but x coordinate, and x coordinate is 0. So cos of 2n pi plus pi by 2 is 0. Now similarly you can write result about sine theta also. Now sine theta is 1. That means sine of 2n pi plus pi by 2 equal to 1. Now this is regarding position B. Now the last point is B dash. About that also we can write certain things. Position B dash corresponds to theta equal to 2n pi minus pi by 2, right? And here also you observe that x coordinate is nothing but 0. That means cos of 2n pi minus pi by 2 is 0. And similarly, I can write about sine part also. Now sine theta should be -1 and theta is 2n pi minus pi by 2. That means sine of 2n pi minus pi by 2 is -1. Now remember one thing. If you have this unit circle figure in front of your eyes, all these results make sense also to you, and then it looks very simple also. All of them, they look very simple when you have understood positions A dash, B dash. Then these results would come automatically to your mind. Without any effort, you would be able to write. If I remove this picture, if I remove these clouds from here, and if I just give you a list of formulae kind of thing, then you will try to mug them up, and which is actually not the right way to understand trigonometry. There is some reason behind every formula, and if you know it, then you will be able to write on your own also, just remembering the figure, that unit circle, and you would be able to write these formulae, right? Now, proceed further from here. Now, what further things I can say? That just now we have seen sine of 2n pi is 0. That was regarding position A. Sine of 2n plus 1 into pi equal to 0. That was regarding position A dash. Now you are seeing that there are two positions, A and A dash, where sine of corresponding angles is 0, right? That means those 2n pi and 2n plus 1 into pi, they are taking my attention because sine of those angles is 0, correct? Now, 2n pi tells it is nothing but even multiple of pi, and sine is 0 there. And 2n plus 1 into pi, that is odd multiple of pi, and there also sine is 0. That means whether angle is even multiple of pi or odd multiple of pi, sine of that angle is always 0. What does that further say? That you take any multiple of pi, even or odd, sine of that angle would be 0. That means this leads to sine of any multiple of pi is 0. This I am writing in language, right? Easier statement. Now, if you want to write it mathematically, then you will be writing sine of n pi equal to 0, where n is any integer. Any integer, when I say, it can be even, it can be odd, anything. Sine of any multiple of pi would be 0, or sine of n pi equal to 0. I hope you gathered the correct language also, statement also, meaning also, and how these statements I am writing with help of unit circle. That also you must have understood. Okay. Now look at the positions B and B dash. Their cos is 0, means x coordinate is 0, right? That means cos of those angles 0. And what are those angles? Those are 2n pi plus pi by 2 and 2n pi minus pi by 2. So this also tells me that cos of any odd multiple of pi by 2 is 0. Now some of you may think that how are you saying odd multiple of pi by 2? Now just try to understand 2n pi plus pi by 2, like what this stands for. This notation stands for angles of the type pi by 2, 5 pi by 2, 9 pi by 2, 13 pi by 2, etc. B dash stands for 3 pi by 2, 7 pi by 2, 11 pi by 2, etc. So now if I talk about angles at B and B dash alternately, so can I say like this: pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, 11 pi by 2, 13 pi by 2. Now you can see a pattern. Pi by 2 is getting multiplied by 1, 3, 5, 7, 9, etc. That means you are talking about odd multiples of pi by 2. So instead of writing two statements, cos of 2n pi plus pi by 2 equal to 0 and cos of 2n pi minus pi by 2 equal to 0, I can write one statement only, and that is nothing but cos of any odd multiple of pi by 2 is 0. Now, if you want to write it mathematically, you can further write it as cos of odd multiple of pi by 2 means 2n plus 1 into pi by 2. That would be 0, where n stands for any integer. Now this is about the x coordinates and y coordinates of positions B, B dash and A dash respectively. Now why I must have written this separately? Because now sine of any angle is 0 or cos of any angle is 0. Now this may trouble me to understand our previous trigonometric ratios which we have learnt in our previous classes. See, what was tan theta? Tan theta was sin theta upon cos theta. Here in denominator cos theta is appearing. Now can cos theta be 0? This we had never thought before when we were doing trigonometry with help of a triangle. That time we have not thought about this situation, that can ever cos theta be 0 or can ever tan theta be not defined. So these type of questions were not there before, but now they are coming because cos theta is becoming 0 at certain positions. Which are those positions? B and B dash. Similarly, just look at that cot theta. Cot theta is cos theta upon sin theta. In denominator you have seen sin theta, and now at positions A and A dash, we have seen sine of those angles have become 0. That means such a sine theta quantity cannot appear in the denominator. So is that not something which is prompting us to redefine our previous trigonometric ratios, which we have already learned. So now it is time to redefine our trigonometric ratios. This is for sure. We have to remove those positions from the picture whenever cos theta is appearing in the denominator and cos theta becoming 0. Similarly, about sine part also. Now, where cos theta had become 0? Cos theta had become 0 at positions b and b dash, and we have already seen cos of odd multiple of pi by 2 is 0. Cos of odd multiple of pi by 2, 0. Why I am saying? Because positions b and b dash together actually are talking about odd multiples of pi by 2, right? Now, for such a position, tan theta cannot be written. Why? Because cos theta is becoming 0. So we will have to remove this angle. So we will write now tan theta as sine theta upon cos theta, where theta not equal to odd multiple of pi by 2. By doing this, we have removed positions b and b dash in definition of tan theta. Now remember one thing, here onwards, if you are writing tan theta, you will have to take care. You will have to write correspondingly there itself simultaneously theta not equal to odd multiple of pi by 2. Where else you had seen cos theta in denominator? We had seen it in sec theta also. Sec theta was nothing but 1 upon cos theta. What are we doing? We are just redefining those previous trigonometric ratios, because such a care is to be taken now. Now, theta not equal to odd multiple of pi by 2. This is additional part along with sec theta also. Okay. Now, these are two trigonometric ratios where in denominator cos theta is appearing, right? Now, recall those where sine was becoming 0 and sine theta appearing in the denominator. Sine n pi is 0, that we have already seen. That is regarding positions a and a dash where sine is 0, right? So at these positions now, cot theta and cosec theta, we won't be able to write. Why? Because sine theta is becoming 0 at these positions. So if I am writing now cot theta as cos theta upon sine theta, then I will have to write there itself theta not equal to any multiple of pi. Then only you can have cot theta. The moment you get theta equal to n pi kind of thing, cot theta is not defined. This is what we are going to write in future. Now, similarly, write cosec theta also. It is 1 upon sine theta, and we will have to write with this theta not equal to n pi. So in this way, remaining 4 trigonometric ratios which we had learned before, we have now redefined or rewritten. Okay. Now from here, you take them as formulae only, like how we have defined sine theta and cos theta as x coordinate and y coordinates of any position P on the unit circle. Now, like that, now we are redefining tan theta, cot theta, and sec theta, cosec theta with their required restrictions. Okay. Now, don't you think that if I have defined now tan theta and sec theta fresh, now I will have to write trigonometric identities also in a fresh way. Now, how do we write? Say, is there any restriction for sine theta and cos theta? No. So we will write sine square theta plus cos square theta equal to 1 and theta belongs to R. Like before, but remember one thing, when you were doing trigonometry with help of a triangle, there you were not writing even theta belongs to R. There your angle theta was always restricted between 0 degree and 90 degree. So of course, this is also a little more broader picture of first trigonometric identity. Now what was your second trigonometric identity? That was 1 plus tan square theta equal to sec square theta. But now with this, we will be attaching one additional condition, and that is theta not equal to odd multiple of pi by 2. Now go to third trigonometric identity. That was 1 plus cot square theta equal to cosec square theta. And here we will be writing theta not equal to n pi. Now understand one thing. These additional conditions what we are writing, this you have not seen before, but now here onwards, you will have to remember and you will have to highlight also these conditions. So we learned cos of any odd multiple of pi by 2 is 0, sine of any multiple of pi is 0, and since they were zeros, so we had to redefine our trigonometric ratios tan theta and sec theta, and similarly cot theta and cosec theta. This is what we have learned in this video along with the respective trigonometric identities and the conditions. Now we will be meeting in next video with something more. Till then, stay tuned. Thank you.